Alright, I'm going to help you out with 5.7, practice 5.7, problem 1. Tom the cat is chasing Jerry the mouse across a long cafeteria table that is 1.5 meters from the ground. Jerry steps out of the way, and at the last second, Tom runs off the edge with a horizontal velocity of 8 meters per second. So once again, we're dealing with horizontal projectiles. The path of his motion is going to follow that sort of trajectory. So I wanted to put that graphic on there just to remind you that when we talk about Tom moving to the right, that's the x direction. When we talk about him moving downward, that's our y direction. Separating those two when you answer these questions is the trick to these problems. So part A asks us, how much time does it take before Tom hits the floor? First thing we have to do is talk about what do we know. We have to talk about our givens. So things that we can see easily in the problem, the first being that the cafeteria table is 1.5 meters above ground. That is the height from which he's going to launch. Height we symbolize as delta y. Because he's falling down from that height, we add a negative to show the direction. Okay, now we also, in this reading, have that he's launching from this table at a speed of 8 meters per second. Now keep in mind, guys, he's launching from the table just outward. Okay, he's running straight off the table, not up or down at all. So when we label this velocity, we don't just call it v, we call it v with that little x, saying that that's the velocity in the x direction that he's leaving the table at. Speed of 8 meters per second. Alright, now there's things that are always true when you're dealing with horizontal projectiles. The first, we've been using it for a while, gravity is going to be negative 9.8. That's how much he'll accelerate as he goes down. The other thing that you need to get down is that since he launched flat out, it wasn't up or down at all. So our velocity initial in the y direction, talking about his motion downward, it starts at 0. Great, and then in this problem they ask for time. So we're looking for delta t. Okay, it's your job to figure out, are we talking about a vertical motion here, or are we talking about, it should say, horizontal. Fix that on the next video. Are we talking about a horizontal motion? Well, we're talking about the time he's in the air. What's bringing him down to the ground is gravity, and we know that gravity is only going to act downward on Tom. That means we're dealing with the vertical direction on part A. So that means we have to use these equations to answer this. So looking at these equations, you have to find an equation for delta t. This problem has nothing to do with velocity final, so we know we're using equation number 2. And if velocity initial is 0, we get to use this equation to make it a lot easier on ourselves. So for part A, that's the equation you'll use. Delta t is equal to the square root twice your height divided by acceleration. So plug in your delta y, plug in your acceleration, solve that for time. Now on part B, we're asking how far from the table does he land? So we're wanting to know, by the end, how far did he get in that direction? Well, that is our horizontal direction. Therefore, we need to use these equations when we're answering part B. So if we're looking for distance, we're talking about delta x. That's what they're asking us for. So obviously, this is going to be the right equation to use. Delta x is equal to your velocity in the x direction multiplied by the time. So we'll use this velocity in the x direction of 8. You'll multiply that by the time you find on part A.